distance formula. So this is a distance formula down here, this big ugly mess, and students never remember it. But they usually don't have a problem memorizing the Pythagorean theorem, and this is just that in disguise. So we have no excuse. If we know this, we can justify this. So if I've got these 2 points, x1, y1, x2, y2, I can draw a little right triangle, and this would be the hypotenuse, so this would be my C, and this length here goes from here to here, so it's the difference of the x's, right? It would be whatever this value was minus whatever that value was. If this were 2, right, and this were 5, then this length would have been 3. It would have been those two distances subtracted, x2 minus x1. And it works whether it's positive, negative, play with it, you'll see. And then this distance here is the difference in the y values. It started off at some y value up here, so it looks like on this graph it's 1, 2, 3, 4, 5, 6, and then here it was 2, so that distance there was 6 minus 2 is 4. It's just the difference in the y values, y2 minus y1, the change in the y. So when I plug in a squared plus b squared equals c squared, I'll have c squared equals x2 minus x1 squared plus y2 minus y1 squared. And then just take the square root of that. Actually, I can call this length instead of c, I can call it d for my distance. And then just take the square root. I left a lot more space than I needed. Just take the square root of both sides and you're there. That's a squared plus b squared. So c is the square root of a squared plus b squared, where a is the change in the x values and b is the change in the y values. As nice as that. And then students always get messed up too between this x2 minus x1, x1 minus x2. Doesn't matter. You're going to square it anyway, right? It's going to be positive no matter what. So if you get those turned around, doesn't matter. So as long as you know there's a plus in the middle there from the a squared plus b squared, you're going to be okay. And then this one's where the minus 1 comes in because it's the change in x and the change in y. So we don't need, there's no excuse, like if we forget the formula, we can just picture it. It's good to know off the top of your head because you don't want to be deriving it every single time you do it, but it's not that bad. Not that bad. Oh, the other thing too is that it's also the same thing as the formula for a circle. The x squared plus y squared equals r squared. That's a squared plus b squared equals c squared, because a circle is made up of a bunch, if it's on an xy axis, the x is this, like for that point there, the x is that, the y is that, and the r is the same no matter what triangle you draw. X squared plus y squared should be r squared. So x squared plus y squared equals r squared, the equation of a circle, is just the Pythagorean theorem. So if we know that, we get a bunch. Okay.